Hello everyone, welcome to the session of Class 9 Mathematics, and I am your Anu from mathschool.1. We are continuing with the chapter 7 triangles, and today we are going to see some inequality relations in triangle. So what do we mean by inequality? Now let's take for an example. We have already seen that in a triangle, if two sides are equal, okay, if two sides are equal, we have seen the angles opposite to them are equal. So we have studied like these theorems which states some equality relations in triangle. So let's imagine if the sides are not equal, if some two, given in a triangle, if two sides are unequal, then what happens to the angles? Okay, so that's what we are going to deal with today. That is some inequality relations in a triangle. So what is given here is, if two sides of a triangle are unequal, they are not equal, they are unequal, then the longer side has greater angle opposite to it. The longer side has greater side opposite to it. Okay, so how do we prove it, or how do we understand it? Okay, so let's draw a triangle having unequal sides. Okay, so let me draw a triangle having unequal sides. Let me name it as A, B and C. So how do I proceed? Now we have unequal sides here. So let's see. With this diagram I can see AB is a shorter side. I can take either AC or BC, which is the longer side. Okay. So now what do I do is, taking this AB to be a shorter side, I mark a point D here. Okay, on AC I mark a point D here such that AB is equal to AD. Now I join BD. Okay, I join BD. Now we have AB is equal to AD. By construction, AB is equal to AD. Okay, I have this. Now we already know that if two sides are equal, then the angle opposite to those sides are equal, isn't it? So these two angles are equal now, right? So I name them as 1 and 2. So angle 1 and 2 are equal. By construction, angle 1 and 2 are equal because these two sides are equal. Angle opposite to them are equal. Now what happens is, if I take this angle 2, now going back to the question, what we are required to prove is, see, the longer side has greater angle opposite to it, right? Okay, so let us take this side to be the longer side. So when this side is the longer side, then the angle opposite to it, the angle B, has to be the larger angle in this triangle. So that is what we are trying to prove. So now let us take this angle 2. We see 1 is equal to 2 here, and if I see this angle 2, okay, so this angle 2 becomes the exterior angle for this triangle. Okay, for the triangle BDC, this becomes the exterior angle, right? So how does, what is the property of an exterior angle? Exterior angle is nothing but, what is the definition? The exterior angle is the sum of interior opposite angles, right? So 2 is equal to angle, see, angle 2 is equal to angle DBC plus angle, see, angle DBC plus angle DCB, isn't it? So angle DCB. So angle 2 is equal to this angle plus this, opposite interior angles, right? So it is naturally greater than any one of the angles. See, angle 2 is equal to sum of these two angles. So angle 2 has to be greater than these two angles, right? Each individual angles. So angle 2 is greater than DBC, and naturally angle 2 is greater than DCB because it's the sum of both the angles. So it has to be, angle 2 has to be larger than, more than the individual angles, isn't it? So let me take this angle, that is angle 2 is greater than angle DCB. See, angle DCB. Why I am concerned with this angle? Because the side opposite to it is shorter. That is what we are trying to prove. So the angle C is opposite to the side which is shorter here. Okay. So let us take this DCB is less than or angle 2. This angle 2 is greater than angle DCB, right? Angle DCB. Now we know that 1 is equal to 2, isn't it? Already we know that 1 is equal to 2. So instead of 1, I am writing angle 1. So angle 1 is greater than DCB, isn't it? So is this true? Yes. Isn't this true? Yes. So angle 1 is greater than DCB. Angle 1 is greater than DCB. Now DCB is nothing but ACB. We can write ACB also. So angle 1 is greater than ACB, isn't it? So what is ACB here? ACB is nothing but angle C. So which implies angle 1 is greater than angle C. So we have one relation here. Angle 1 is greater than angle C. So keep that in mind. Now we'll come to this angle. Now what is B here? Angle B is a sum of angle 1 and angle DBC, right? So what can, we can write this as angle B is greater than angle 1 because B includes angle 1, which means angle 1 is less than B, or B is greater than angle 1, right? Because angle B is sum of angle 1 and angle DBC, isn't it? So I can write angle B is greater than angle 1. Do you understand what I am saying? Angle B is greater than angle 1. Since angle B is greater than angle 1, okay, see we have a relation here, angle 1 is greater than C, right? 1 is greater than C. So naturally angle B is also greater than C. So can we write this like this? Angle B is greater than angle C. Okay, angle B is greater than angle C. So if angle B is greater than angle C, which means the sides opposite to them, see the side opposite to angle B, that is AC, and the side opposite to angle C, AB. So we can write AC is greater than AB. So AC greater than AB. Now we have proved that the longer side has the greater angle opposite to it. See, longer side, which is the longer side? AC is the longer side, and opposite to AC is B, and B is greater than C. Okay, so likewise we can prove the inequality relations in a triangle. Okay, do you understand the inequality relation? That is just like when two sides are equal, the angles opposite to those two sides, equal sides, are equal. So this gives an equality relation in a triangle. And here we have proved if there are sides, if there are two sides which are unequal in a triangle, then what happens? The longer side has the larger angle opposite to it. Okay, or the longer side has greater angle opposite to it. Do you understand? So this is one of the equality relations in a triangle. Please take a note of it. We'll move on to the next inequality relation. Hello everyone, welcome back, and we are seeing about the inequality relations in the triangle, and the second inequality we are going to deal about is the sum of any two sides of a triangle is greater than its third side. So how is it possible? So let's take a triangle. CABC is a triangle. So what does the relation says? The sum of any two sides of a triangle is greater than the third side. So let's explain it like this. See, AB and AC. Let us take AB and AC. We can prove it for any set of two sides. Okay, like AB plus AC will be greater than BC. Likewise, AB plus BC will be greater than AC, or AC plus BC will be greater than AB. See, all the three conditions can be proved, but it's enough if we prove for just one relation, one equality relation, and similarly we can follow the same steps for the other two also. Now let's take the first relation, AB plus AC is greater than BC, and try to prove the inequality relation. Okay, so now in the triangle ABC, I am extending AB to D. Likewise, what we did in the previous problem, I am extending AB to D such that AD is equal to AC. Now here AD is equal to AC. Join this DC. Okay, what do we have? AD is equal to AC. So let us consider this part of the triangle. Okay, so because I made AD to be equal to AC, let us consider this part of the triangle. And what do we have? This angle is equal to this. That is, when two sides are equal, we have the angle opposite to them to be equal, right? So what do we have? See, these two angles are equal now. So let's take it as angle ADC is equal to angle ACD, right? Angle ADC is equal to angle ACD. Okay, now what do and what we need to prove is, we need to prove AB plus AC is greater than BC. We need to prove that it is greater than BC. Okay, so it is greater than BC. So let us consider the angles. See, this angle is more significant here in this problem because this is the angle opposite to BC. So indirectly what I need to prove is this angle to be less than the sum of other two angles, because BC is less here, because the other two sides, see, sum of other two sides is greater than BC, right? If it is greater than BC, then BC has to be the shorter side. Then BC, the sum of those two sides will be greater than BC. Then the angle opposite to BC, we prove that it is smaller, okay, than the sum of the other two angles, then we'll be proving it right. Okay, we can prove this relation. So now we have ADC is equal to ACD. Okay, now we have ACD here. If I add ACD with this, with ACB, I'll get this angle, that is BCD or DCB. See, I need to add these two angles now to get this angle. Now ACD is equal to ADC, isn't it? So let it be. Now what do we have is, since these two are equal, what happens is, if I add BCA to this ACD, angle BCA plus ACD, what happens? This becomes larger, isn't it? Because we are adding ACD, we are adding some amount of angle to this, a measure of angle to this ACD. So naturally it becomes greater than this angle, isn't it? So when I add BCA to ACD, then the sum becomes greater than ADC. So I write this as, now the equality relation becomes inequality relation. Do you understand? When I add BCA to ACD, then this sum becomes greater than ADC. Earlier it was equal. When ACD, it was just ACD, they were equal. Now I add BCA to it, it becomes greater. Do you understand? So BCA plus ACD is greater than ADC. But what is BCA? BCA plus this BCD, let it be like that, BDC. Now what is this actually? What is this angle BDC? This angle, ADC is nothing but BDC, right? So I write BCA plus ACD is greater than, instead of writing BDC, I write ADC, I write BDC. Okay. So instead of writing ADC, I write BDC here. Right. Now what happens is, what is the, angles BCA plus ACD becomes, what is that angle totally? That becomes BCD. Angle BCD is greater than angle BDC. Now what is this BCD? BCD, the angle, the side opposite to this is, see, we have written angle BCD, we have added these two angles, we got BCD. And what is the side opposite to it? Side opposite to it is BD. So BD is greater than, what is the side opposite to BDC? That is BC. Do you understand? So let me write it here on top so that it will be easy for you to see. Now we have BD is greater than BC. Do you understand? Did you get how we got the step here, BD greater than BC? Because we know BCD is greater than ADC. So ADC can be written as BDC. So BCD is greater than BDC. Now the side BD is just opposite to BCD. So I have written BD here, and the side BC is just opposite to BDC. I have written BC here. So BD is greater than BC. Do you understand? BD is greater than BC. But what is BD here? BD is nothing but, we have extended this, isn't it? So BD is equal to BA plus AD, which is greater than BC. What is AD here? By construction, AC. It is equal to AC, right? AC has been marked there. So BA plus AC is greater than BC. So I rewrite this BA as AB. AB plus AC is greater than BC. So I have got the inequality relation. See, AB plus AC is greater than BC. So now this proves the statement, the sum of any two sides of a triangle is greater than its third side. So hence we have proved this. Do you understand? So what we have done, we have extended BA to a point D, and such that we AC is equal to AD, and then we have joined DC. Then we know that for equal sides, the angles opposite to them are equal. So these two angles are equal. If I add this angle to this, it becomes greater than this angle. And the side opposite to this angle is BD, and the side opposite to this is BC. But this BD is nothing but BA plus AD, and AD is nothing but AC. So that is what we have got. AB plus AC is greater than BC. And that is how this inequality relation is proved. Now do you understand? So just check out this, and we'll move on to yet another inequality relation. Right? Hello everyone. Hope you have understood the previous two inequality relations in a triangle, and we'll see yet another inequality relation here. Of all the line segments that can be drawn to a given line from a point not lying on it, the perpendicular line segment is the shortest. Now to understand, let's draw this. See, we have a line here. Okay, there is a line segment, and there is a point here. Okay, some point not lying on it, not lying on the line given. Okay, so from a point not lying on it, of all the line segments that can be drawn to a given line, of all the lines, see, I am drawing many lines like this from the point, okay, to the line. See, there is a point. So let me take this point as P. Okay, so from a point P which is not on the line, so let me draw it clearly. See, I'm drawing a line segment here. There is a point P which is not on the line. From the point P, I'm drawing many lines to the line segment. Okay. This point is not on the line, somewhere else out. Okay, so from P, I've drawn many lines to the line segment. Okay, of all the line segments that can be drawn to a given line from a point P not lying on it, the perpendicular line segment is the shortest. So the perpendicular line segment, out of all the lines, I've drawn a perpendicular line to which is 90 degree with the line segment. What they have given is that the perpendicular line segment to the given line is the shortest of all the lines. See, we have drawn many lines, and this is the shortest. Now we need to prove that this is the shortest. Okay, so for that, what I do is I redraw the line with only one line other than the perpendicular line. See, this is a point P. It touches the line segment at M. Let us take any one line which is not perpendicular. Okay. So let us take only one line and we need to prove that this PM is less than the line PN. PN is greater than PM. Okay. So that we need to prove here. Now we know that in a triangle, if one of the angle is right angle, then the other two, what about the other two angles? We know according to angle sum property, according to ASP, by angle sum property in a triangle, all the sum of all the angles, that is angle P plus angle M plus angle N should be equal to 180 degrees, right? According to angle sum property, all the angles should add up to 180 degrees, right? Now we are given with M as 90 degrees. Angle M is equal to 90 degrees. So what can you say about the rest of the angles, angle P and angle N? See, angle P plus angle N should be equal to 90 degrees, isn't it? Then, according to ASP, then only we'll be getting 90 plus 90, it is 180 degrees. So, if M is 90 degrees, then the other two should add up to 90 degrees. So, if I say other two angles, see, P plus N is 90 degrees, then either P or N both are acute. Okay. So, P and N both are acute. So, P and N has to be acute angles. Acute is less than 90 degrees. If it is less than 90 degrees, then it says that P, either P is less than M or N, angle N is less than M. Do you understand? So, N is less than M and P is also less than M. So, what does it state? See, M is here. So, 90 degrees, M with 90 degrees is the greatest angle in this triangle and the rest of the angles are smaller. So, the side opposite to M, what happens? Side opposite to M, PN, okay, side opposite to N is greater. According to our first inequality relation, we said the longer side has greater angle opposite to it, right? So the greater angle is given here, so the side opposite to it will be greater. So PN is greater than MN P, isn't it? Because see, angle P is here, the side opposite to angle P is MN here. So PN is greater than MN and also PN is greater than, see, angle opposite to, side opposite to angle N is PM, right? PM. So PN is greater than PM and PN is greater than MN also. But we are concerned here with the line from the point P to the line segment. Here PN is greater than PM. With the second relation, inequality relation, we have PN is greater than PM. So naturally, any line which is not perpendicular, see, any line which is not perpendicular will always be greater than the line PM, which states that PM is the shortest line, a line which can be drawn from P to a line segment, that is from a point not lying on it. So we are given with a line segment and we are having a point P somewhere, not lying on it, somewhere else, not lying on the line segment. Then the line drawn from the point P to the line segment, okay, the lines are drawn from the point P to the line segment, and out of which the line which is perpendicular to the line segment is the shortest, or the distance between the point P and the line segment, distance between the point and the line segment will be the shortest if the line is perpendicular, if the line is perpendicular to the line segment. Do you understand? So PM is less than PN. PN is greater than PM means PM is less, shorter. So the perpendicular line from the point P to the line segment is always the shortest. Do you understand? So that is how we prove this inequality relation. This is an important relation also. What we are looking from, first we have seen three inequality relations. All these are important. Okay, so with this I end this session, and in the next class we'll have another set of inequality relations and we'll be seeing it. Until then, keep revising. It's bye from Anu. Thank you.